Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi and we continue with our topic of discussion, a topic in Form 2 chemistry, and this is structure and bonding. Now, we are going to see the various ways of illustrating ionic bonds, and during our last lesson, we saw an example of how to illustrate by use of a dot and cross diagram the structure of sodium chloride. So today we are going to illustrate formation of magnesium fluoride. So magnesium fluoride is also an ionic compound because magnesium is a metal and therefore it forms a positively charged ion. Fluorine is a non-metal and therefore forms a negatively charged ion. So the attraction between the positive and the negative ion creates an ionic compound, which is magnesium fluoride. On the other hand, we can say that magnesium loses electrons while fluorine gains electrons. And that's what leads to the formation of the ionic bond. So in this case, we can say that magnesium, this one has 12 electrons arranged as 2, 8, 2. And we are saying that it therefore requires to lose 2 electrons. Fluorine, this one has 9 electrons arranged as 2, 7, 2, 7, and requires to gain 1 electron. So that's the bottom line, that magnesium with the 12 electrons, that is the arrangement, 2, 8, 2. For fluorine, 9 electrons, the arrangement is 2, 7. So for magnesium is going to lose 2 electrons, while fluorine is going to gain only 1. It has only the capacity to gain 1 electron. So what will happen here is that the 2 electrons that are lost by magnesium can only be gained by 2 fluorine atoms, because each fluorine can only take 1. So basically what we are saying that we need 2 fluorine atoms to combine with 1 magnesium atom, so that when magnesium loses the 2 electrons, each of the fluorine atoms can gain an electron from there. So on this, we'll draw the diagrams for that. Magnesium 12P, 12N. Can use a different illustration. So that is 2, 8, 2. That is for magnesium. Atom Mg 282. So it's important that all these details, we include them. The electron configuration at the bottom. Then we are saying plus fluorine. Fluorine is 9 electrons, so it has 9 protons and 10 neutrons. So the number of neutrons have no effect here. They just add to the mass of the atom. So 2, 7. This is a fluorine atom, F 2, 7. So we are saying that because magnesium is losing 1, 2, and fluorine can only take 1 here, so we shall need 2 fluorine atoms. So here we'll say 2 to show that these are 2 fluorine atoms, so that when you draw it, now we have magnesium 12P 12N after it has lost the 2 electrons. So now the number of protons are 12 and the electrons are 10. So we have an excess of 2 protons, so 2 positive charges. Fluorine, we are saying there are 2 fluorine atoms. You can either put a 2 here to show that there are 2, or you can draw them separately, but each will gain only 1 of the 2 that are lost by magnesium. So we'll have fluorine, the nucleus is 9p 10n, remains the same. The first energy level not affected, but the second energy level gains an electron. So initially it was like that, 2, 7, but now it has gained an electron here from magnesium. Because it has gained an electron, so the electrons are more than the protons by 1, so we put a negative charge here. Put a negative there. And then because we had 2 fluorine atoms, we'll also have 2 fluoride ions. So magnesium ion Mg 2 plus, and this is 2, 8 as the arrangement because it has lost 2 electrons. 2 positive because 2 electrons have been lost. This is a fluoride ion F negative, and these are 2, 8, and there are 2 of them. 2 fluoride ions. And you can say that the compound formed is magnesium fluoride, which is MgF2, because we have 2 fluoride ions combining with 1 magnesium ion. So the formula is MgF2. We used 2 fluorine atoms because magnesium is losing 2, but fluorine can only gain 1. So we can also have another one of formation of magnesium oxide. And this one we can directly go to the diagram. So magnesium and oxygen. 12p 12N. So that is magnesium. (282) plus oxygen. Oxygen is 8P8N. We use the dots here. So the arrangement is 2,6 because the total number of electrons. So oxygen is 2,6. So we say that oxygen atom arrangement is O2,6. So in this case, we are saying that magnesium is losing 2 electrons and oxygen is gaining 2 electrons to attain a stable arrangement. So the 2 electrons lost by magnesium will be gained by oxygen. So the diagram after that result that diagram will not fit here. Let's just is a continuation. Let's have it here. The product. So we'll have 12P, 12N for magnesium. So these will be 1, 2. We usually put the electrons in pairs unless it is 1. So that is 2,8 magnesium after losing 2 electrons. So after losing 2, it acquires 2 positive charge. Then we have oxygen. Oxygen was 8P8N. The arrangement was 2,6. Now it is 2,8 because it has gained some 2 electrons here from magnesium. So by gaining, it acquires a charge that is 2 negative. So this is a magnesium ion, Mg, 2 positive. The arrangement is 2,8. Oxygen forms an oxide ion. So O2 minus, like that. And the whole of this compound is what now we are referring to as magnesium oxide, because it has a magnesium ion and an oxide ion. So there's something that is important to note here, that for nonmetals, when they form their respective ions, their name changes a bit, and we add an IDE at the end. So for oxygen, we have oxide. For chlorine, we have chloride. For fluorine, we have fluoride. So, but for the metals, the name just remains. Magnesium remains, calcium remains, sodium remains. But for the ions of nonmetals, these are the ones that we add an IDE at the end. So hence oxide, not oxygen ion, but oxide ion. Not fluorine ion, but fluoride ion. So the assignment, the first question, using a dot and cross diagram like the ones we are drawing, show bonding in potassium oxide, calcium chloride. Number 2, name the ion formed by phosphorus and hydrogen. So we are going to stop there until the next time. Goodbye.